In this video, we're going to tackle the solution to the level width problem. So remember, this is going to have a lot of code that looks very similar to a breadth first traversal, but at certain locations, we're going to decide to do some extra amount of work. And this is a very common thing to do in all type of tree problems. Very frequently, you will be implementing a depth first or breadth first traversal, but you will add in some extra code to execute at some given steps along the way. So let's get to it. Now, we went through a very long solution in the last video, so we're going to kind of, go pretty quickly here rather than reiterate a lot of all the different steps here, but I might refer back to the diagram once or twice. So step one, and I will show this in the diagram, step one will be to create a counters array that's going to hold the width of our tree at each level, and we're going to initialize the first value in there as 0. And then we're also going to create this array that's going to hold kind of the buffer or all the working elements or the queue that we are waiting to process in our tree. And we're going to make sure that we initialize it with values from the first node of the tree or the root node of the tree and whatever our stopper value here is. Remember, the stopper value here, it doesn't have to be S. I just totally made that up. It could also be null. It could be undefined. It could be absolutely whatever. It just needs to be some value that we could recognize as symbolizing that we've hit the end of a row. Now, the string S is totally okay, because remember, 20 here is a node. So 20 is actually on the data property of the node. So even if we had some node that contained the character S, we would be totally fine, because this is the character S. This is a node that contains data of S. All right, so with that in mind, let's get to it. We'll say const array will be our root node. And again, I'm going to use the character S here just to stay consistent. And then we will also initialize that counters array, which is going to hold the widths along our tree. Now, you could have just as easily called this thing widths. Maybe that would have been a little bit more clear as to what its purpose is. But, the word widths is really easy to misspell, I think. I kind of like counters, nice and simple. So now we're going to iterate through our array right here. But as soon as we write the bounds here, remember we had previously said as long as there is still an element in array, we want to continue iterating. But when we get down to the very, very, very last case here, after we have processed everything, the last element in the array will be S. And in that case, we don't want to take the thing out and then put it right back in. We want to say if S is the only thing left in here, then get me out of here. I don't want to do anything else. So we're going to say while array.length is greater than 1. So as long as there's more than one thing in here, that means that there must be some more amount of work for us to do. Now inside the while loop, we'll pull off the next working element with shift. And then there's two considerations that we want to make here, or two different conditions that we want to process. The first will be the case in which we pull out the value S. So if we pull out S, we want to increment, or excuse me, we want to add a new index to our counter, or a new element to our counters variable, because S means we've hit a new row. And then we also want to add S back to the very end of our array. So if the node that we're now looking at is the character S, if that is our stopper character, then take our counters variable and push on a new element of 0. In other words, counters needs to be informed that we are now going to start processing another row. And then the other thing we need to do is array.push S. So put that thing back at the end of the array. Now the other case that we need to handle is the case in which node is an actual node, like the node 20 right here. So if we are working with an actual node, then we want to make sure that we take all of its children and stick them into the end of our array. And because we have visited a legitimate node here, we'll want to make sure that we also increment the last value in our counters index. So if we are not working with the character S, if we are working with the character node, or excuse me, an actual node here, then we want to push all of that thing's children, so node.children, into our array. And then we also want to make sure that we increment the last value inside of counters. So we'll say counters at counters.length -1 ++, like so. So find the very last element inside of counters, increment it by 1. Remember that the last element in counters represents the current level of our tree that we are working on at this point. All right, just one last step here after the while loop. So after we have processed everything, we need to make sure that we never forget to return the thing that we actually care about, which is the counters array. So let's save this and check our tests, see how we're doing. And we're passing. So that's pretty much it. Again, I've said it twice now, I'll say it one more time. Whenever we start working on problems related to trees, we are usually going to have to end up implementing either a depth first or breadth first traversal manually. So very rarely will we be able to really do any type of very generic iterator function here. I think that you probably could have in this problem, but very frequently we'll have to do some extra stuff along the way. So this is just one possible way of solving this, but it is one that is very easy to remember because we're building on that very straightforward or rather simplistic way of iterating through our tree in a breadth first fashion. So let's now continue into the next video and start working on our next problem.